this is up to about 189 millimeters because of the way the objectives are set up. I've got a different objective on here. So the thing is, that this, I'm just adding to the specs that you should have already memorized on those sheets.
With what time?
Yeah, at the same time that you like sleeping last night instead of doing
Yeah,
it.
right. Didn't even get
Just
there.
like
I
me,
got
right.
5 hours of
Okay,
sleep.
the thing is that when you're gonna sell a microscope, the first thing you need to do is ask the customer, what are they doing? Are they looking at a mouse? Are they looking at a slide? Are they running a biofluorometer? What are they really doing? Most people that call us up and are buying microscopes are doing dissection, whether mouse or rat or something like that. So they're gonna be wanting to buy one of the stereoscopes, not one of these. Okay? The thing is that, we've got this particular stand that Perry came up with the dark field option. So you can set that up and actually see a very clear view of the pipettes. In this particular case, that's for zebrafish. A zebrafish is a near transparent animal. And when you set it up with dark field, you can actually see that. So you can, and we just put a couple of pieces of glass on there so you can actually see that dark field operation. We buy this stand and we put all the scope parts on here. The camera system is something that we can add onto it. So this is the PZM T3 MI stand with the Pro 300 camera. There's a camera comparison chart that gives you information on the cameras as far as resolution, field of view, things like that. The primary thing with a stereoscope you're dealing with is most people think of magnification. Throw that out the window. That's bad thinking. Think of field of view. When you're dealing with one of these particular microscopes at its minimum field of view, it's like 30 millimeters. You can zoom up to about 5 millimeters. That's standard out of the box. When you add the long working distance option, this divides the field of view or multiplies the field of view by 2. So now it's up to like 40 millimeters. You put the eyepieces, the 20x eyepieces on there, multiplies it back up to its standard configuration, except you have a longer working distance. So that this is why we push the LWD option. People can get their hands under there and work. With something like this that's normally only like half that distance, 80 millimeters, they can't get under there with their hands and tools to work on it. So that's why we push that LWD option. When you look at that electrode under this microscope that we're looking at, you look through this eyepiece, you're going to see exactly that same image. So when an instructor is teaching and he's doing a surgery under here, and your students are watching that, they're seeing the same thing. Normally, when you're dealing without the doubling objective, they're only seeing this little tiny field of view. So if the professor's working over here doing a dissection, nobody can see that on the screen. So we also call that LWD option the teaching option. So the thing is that you'll see on your charts that I got the boom stand listed. Most popular microscope combination is the boom stand. People want to be able to work on it, swing the scope out of the way, move it up and down, things of that. The regular stand scopes, they're about number 2 as far as that goes. So that's pretty much what we're dealing with, is that the number 1 scope is either going to be the PZM3, PZM4, and you got the option of the long working distance objective. That's primarily what you're going to be dealing with when somebody calls in and says, I want to buy a scope. You need to ask them, what are they doing? That's the first thing. What are they working on? Are they doing a dissection? They looking at a slide? You got a scope that you're going to use with a biofluorometer, which this one you can do that with and do spectroscopy. Are they going to be using a camera so they can get the trinocular option? What kind of a stand are they looking at? We've got like 4 or 5 of them listed. You can see them in the catalog pages. You need to buy a focus mount when you do that. The regular configuration is this comes on a post stand, this one comes on a track stand. Each one of them has different eyepieces and things that's mentioned in those sheets there. So that when usually when somebody calls up, I'll walk them through the benefits of the PZM3 or the PZM4, depending on which microscope they want to use. This is a little bit more difficult to use because it's straight down parallel beams. You see 3D. When you look through these 2 eyepieces, you see a 3D image. of what you're looking at, just like a ViewMaster. For those of us who are old enough to know what a ViewMaster is. So the thing is that, yeah, so I set this up for 20x eyepieces
Nice.
for the long working distance. You can take a look at that. This is the LED illuminator. Over here we've got the incandescent, which is called the Z-Light right now. As far as that goes, I see the people have been moving things around. This one has phase contrast. Like I said, this can be used with the biofluorometer. It's mostly for slides or for like the Floridish, which is wandering around here someplace. This is a good slide observer for somebody who's doing histology, and some of the other applications that I got listed in there. That's on the second page for the microscopes, where you're going to see the W30S LED. Once again, you know, the most important thing, don't worry about magnification, it's field of view. What are you looking at? How much? Then you can talk about magnification. Magnification is an illusion. You know, basically just hold up your eyes and then hold up your hands like this, and then you're going to see everything in that circle. Well, you can make that circle smaller and then stretch it out a little bit more. That adds more magnification. The objective, in the world of optics, the objective gives you the resolution. All these do is magnify the blur. So if you got a blurry objective, eyepieces don't help you. You got to have a clear view from the objective. Like I said, this is a parallel beam. This one is angled at like 6.5 degrees. It's more natural to use the PZM3. So what I want you to do is come over here and take a look through the microscopes, fool around with them, change the zoom, change the focus. Question.
That's the 4 you pointed at, isn't it?
That's a PZM4.
Yeah, which one's the parallel beam? Which
The
one's
PZM4.
angle? Okay.
We got the surgical scope over here. This is also a parallel beam microscope. Is it powered up? Yeah. This has got, what's so special about this, it's about half the magnification of these, but it's got handles on it. So you can move it around, you know, so and the working distance is about that deep.
But that
Right
one's
out of the
not,
box.
is that one trinocular?
No, this is the binocular version of the PSM B5N. This is the Trinoc version over here. It's got the camera port and the beam splitter. This, you can add that on there with this. I just happened to put this one together because this is a 5-step. We were selling, this one's like 15 years old. This is 3 steps. Turn the knob for the zoom. This has got 5 steps. We own this. It's made in China for us. Nobody else can sell the 5-step. But you'll see this microscope all over the world on Alibaba and things, but they can only offer the 3-step. That's an WPI exclusive.
What about a rotating, tilting head? I would just...
No, this is
Does
what
not-
we've got.
It does not tilt. We don't have a tilting head?
Well, the thing is that the way this head rotates is like this. You know, tilts up and down, goes up and down with that, but this is now the tilting operation of this particular head. On that one, it used to just tilt up and down and spin around this way. They've been changing this off and on. So this is what we're offering right now for that particular one.
Jim, you said the PZM4 is harder to use. Why? In what way?
It's because it's a parallel beam. You're looking straight down on 2 sides like you've got a 3-dimensional object down here. So one eye is looking this way, one eye is looking this way rather than at an angle.
You have no depth.
But yeah, so
So how does that equate to me being harder? Is it more adjustment of the eyepieces to get it right? I mean,
yeah,
do I have to look
the
outside
eyepiece
through it? I mean,
position
what's different?
where the center of the eyepiece is where you want the pupil of your eye to be. It's really tight to be exact in order to get a good 3D image. When you look through the PZM3, it's a lot more natural. You can just look through it and everything's in focus and everything's in 3D. It's a lot harder to use the PZM4. Some of our customers cannot use it. They cannot use a ViewMaster. They're going to send this back.
Why opt for the parallel view?
Why what?
Why opt for the parallel view? Why make that? Why make it so it's like that instead of it being on angle?
Well, yeah, this is basically it's just the way it is. I mean, that's a parallel beam. People don't have problems with that, but they do with this. Don't ask me why. It's the same customer
Okay.
or the same group of customers. They might Some people cannot see 3D anyways, because they have like a lazy eye, a lazy muscle in the eye. They're never gonna be able to use any of these dual beam microscopes.
But in
So
the
then the
Trinaculars,
Holloman-
there's a difference.
But the thing is that I've run into quite a number of people who hate the PZM4. But as soon as we get them a PZM3, they're happy.
So the major advantage of the 4 is the teaching option, give you the wide field.
No, we've got the teaching option for the PZM3 as well.
But it's
It's just different, it's just different.
Yeah, so
version.
what,
It's a working
if
distance.
the 4 is
Yeah.
harder for a
It's
lot
the
of
working
people,
distance.
just the working distance, that extra little bit
It's,
is,
I don't know if it's the working distance or what. I'm not a physiologist, I'm not an ophthalmologist, I don't know why.
No, but
But
you have a
the-
difference in the trinocular between them. One's a true trinocular and the other one is a...
They're both
T
true
split.
trinocular scopes.
Oh, they both are
They
now?
both are now, yeah.
Okay, never mind.
And, we got rid of the switch in the PZM3. They're not true zoom. Now, that's another option that costs you about $1,000. That means when you zoom up to a particular level, it stays in focus. Sorry, you have to refocus after you change the magnification on the zoom. That's a real expensive option. You can get that with Nikon or Olympus. We're not going to carry something like that.
which one breaks easier when you drop it?
Actually, the PZM4 is heavier. It's about 5 kilograms. It will shatter. The PZM3 will probably bounce. But the thing is, you flip either one of them upside down, the eyepieces are going to fall out. Pretty much.
Okay, sorry. Can I just clarify one thing?
No, go ahead.
Okay, so the advantage of PZM4 is the longer working distance.
No, they both have it.
As an option, Jim, the standard 80.
Why,
No,
okay,
no, they
why,
both have
why
that
do,
option.
why would I want to buy the 4 instead of the 3?
Some people would like. Some people want a parallel beam design over the Greeno design. That's what the other design is called, by the way.
So the 3D viewing can be of benefit if you can.
They're both going to do that.
What?
But before you said that one was better because of the working space.
Well, no, you can add the LWD option on this and be focusing. You can have this the bottom of this microscope up here. If I would put the 0.5x objective on here, it'll be up here.
So the only thing I can really see the difference is lighting. One's
Yeah,
LED
this is a
and
nice
the other
lightweight.
one's-
This is like about 2 or 3 pounds. This is about 5 to 10 pounds. No, closer to 5 pounds. It's a little bit heavier scope. It's a different optical design. Some people prefer it over
But in
the other.
effect, it makes no difference.
There is a
Really
slight
intrigued
difference.
there.
When you get your eyes over here and stick them on the eyepieces, you will see the differences.
Okay.
And that's what I invite everybody to do at this particular point in time.
Wait, Jim, I have a question. Is the working distance indirectly related to the field of view? Okay, then.
It is
how-
directly, not
It
indirectly.
is directly related.
Yep,
How-
magnification, field of view, working distance are all directly related to the objective design.
Can you relate the field of view to applications? I know it's in
I did.
there. Huh?
I did. If you weren't here, you missed it. I started before everybody walked in the room. Because I'm limited time. But yeah, it is important. It's the field of, minimum field of view, if you look at the specs. If I zoom all the way back, I might be seeing 34 millimeters in the field of view. If I zoom all the way forward, I might be seeing 5 millimeters in that. So yeah, that does make a difference. And then with the, on the PZM4, it has a 1x objective that's screwed into place. It has an 80 millimeter working distance. I have to take that lens off and go to the 0.5x in order to increase that to 189.